Hi everyone. For my research and development topic, I designed affordable runoff control systems for bridges. So basically, containment systems are temporarily placed enclosures on bridges that are used to prevent contaminants from escaping the surrounding environment where maintenance activities are carried out, such as cleaning or painting the bridge. They can be hung from a scaffold or could be built from the ground upwards to the bridge. Currently, they're really expensive due to the scaffolding, wrapping material cost, and the labor and time it takes to carry this process out. So my research question is to develop a cost-effective containment system for these bridges. So for my research, I looked at two regions, Waikato and Bay of Plenty, as these regions have the most amount of water bodies present. And it was unclear how many bridges there were and how many of them were crossing water bodies. So what I did was develop a database. This held information such as what material the bridge is made out of, how big the bridge is, the length, and is two-way or one-way. So this information will allow me to create a suitable containment system. What was found out is Waikato and Bay of Plenty bridges are mostly made out of reinforced concrete. Most bridges were either approximately 80% crossing water, and approximately 20% of them are low-lying bridges. They don't cross water. But however, a containment system is needed regardless when a maintenance activity is carried out. So to develop these containment systems, I had a design criteria. It had to be functionable. It needs to contain these contaminants, need to be cost-effective, lightweight, flexible. Can it easily move along the bridge, and is the material easily bent without cracking? It had to be durable, and it had to be environmentally friendly. So in these initial concepts, instead of having a material to create the barrier or the containment, I had water. So a water curtain is formed to create the barrier. So when the person is water blasting, the water is deflected back onto the water curtain so it doesn't let any contaminants escape. But on the rail of the bridge, the metal bracket along with the arm was placed on the ridge of the bridge to hold the pipe where the water will be falling down. But this could damage the bridge or could add a lot of weight. So I developed robotic arms to hold this pipe and able to form a water curtain. But this would be really expensive to do. And the third concept was to have a long vacuum hose so that you can easily move along the bridge, but this wouldn't fully capture all the contaminants. So in my final concept, this was catered towards bridges that cross water, as this is the most common type of bridge found in these two regions. So instead of having scaffolding, there are inflatable tubes attached around the bridge, and the material, which is vinyl coated nylon, is attached onto the inflatable tubes and contains the contaminants. From the water blasting, the water is built up in the middle of the material, and underneath the material there's drainage pipes. The water is directed into a pump which has a filter called spiral round membrane, which filters out the contaminants, and this water is then pumped back into the water truck to use again. This concept is very flexible, is very cheap. It could be moved along the bridge easily and will save time and effort. Therefore, this was my final concept. thank you for listening to my project to design. I hope you all enjoyed it.